Now we're going to decode a message. So we're going to use the inverse of A below to decode the cryptogram. Now, just as an FYI, looking at this matrix here, this is the matrix that you start with. This is A, and so the inverse is this one. So just remembering, so for your homework, you're going to actually have to find the inverse. So if we started with this, remember how to find the inverse of this? So just as a reminder before we start, you have 1, -2, 2, -1, 1, and 3. This is your coefficient matrix. And then we want to use our identity. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And then remember that you want to get the identity on the left side. So this is A. And then when you do that, when you get the identity on this side, then you'll have your inverse on this side. Okay, so in this case that we're doing, we skipped the part of finding the inverse of the matrix, but in your own example, you are going to have to find it on your own. It's just going to give you A, and then you have to find the inverse. So now what we're going to do, so say we already found the inverse, we're going to use that inverse to decode the cryptogram. And so what we're going to do is that since this is a 3 by 3 matrix, 3 by 3 matrix, then what we're going to do is we're going to write 1 by 3 row matrices. So for example, if you're given a 2 by 2 matrix, then you're going to write a 1 by 2 row matrices. Okay, so what we're wanting to do is we're going to split this up into groups of 3, and they should work out. Then what you do after you do that is you're going to multiply this. So it's 13, -26, and 21. You're going to multiply that to the inverse, -1, -10, -8, -1, -6, -5, 0, -1, and -1. So just to show my work here, just to start this off, is 13, so the row by the column, so 13 times -1 plus -6 times -1 plus 21 times 0. Then we have 13 times -10 minus 26 times -6 plus 21 times -1. Then we have 13 times -8 minus 26 times -5 times, plus 21 times -1. And then actually I missed a negative at the beginning, and this should be a -26 right here. So then when you multiply this and add it all the way through, then you would get 13, 5, and 5. And then you repeat with the next group. So we finish with this group, then you do the next one. So 33, -53, -12. And you multiply that to the inverse matrix, -1, -10, -8, -1, -6, and -5, 0, -1, and -1. Okay, and then when you do that, just to give it to you, this is 20, 0, and 13. Of course, you have to do this work here to figure it out, multiplying the matrices. And so finish it out, and what you will do once you are all done, so once you are done, you are going to look at these values here, then go all the way back to the beginning. Then you look here, and then you use the letters that correspond. So M, 13, so that is M, 5 is E, E, and then 20 is T. This is a space, and this is another M, so it should look familiar. But anyways, it's practice on how do you decode a message. So finish this out. See if you can finish this all the way. So here it is. If you decoded it correctly, I guess it's a way you can double check, because then if it didn't come out right, then you know something happened and you can correct your arithmetic. So you should get meet me Monday. So here is an example for you to try from beginning to end. You're going to use the inverse of A to decode the cryptogram. So this is A. You actually have to first find the inverse. So find the inverse first, and then you're going to do the same thing that we did on this side, is multiply, right? Group it by 3s, and then multiply to that inverse. Okay, so from beginning to end, try this out. So if you tried it out to find the inverse, you would do this, and then hopefully you got it. It was -2, -3, 1, -2, -3, 1, and -2, -4, and 1. Now with that, you can use it to multiply, grouping these by 3. So I put commas just to help me in visualizing it. And then I multiply each, and then you decode everything, and you find that owls are nocturnal. So what's cool about this is if you think about data encryption, so data encryption technology uses algorithms based on the material presented here, but on a much more sophisticated level. So, of course it has to be sophisticated. We want everything that we do online to be, safe if we try to buy things. So it's just kind of neat to know how it's connected.